Hey everyone, welcome to episode 3 of the Oktant Build in Public video series. In today's video, I'm going to take you through the steps I took to go from a web app prototype to a functioning web and mobile experience, and how the Oktant tech stack evolved over the journey. As a quick recap, I'll touch on what Oktant is and what we built in the first 2 episodes, where we put together the product landing page and then built a functioning prototype to solicit customer interest and feedback. I created Oktant to be an operating system for self-actualization, a holistic personal growth platform designed to help us all be more and not just do more. Through regular self-calibration, gamified goal setting, and continuous tracking, Oktant transforms what's often an abstract concept of living our best lives into a tangible, measurable journey towards personal alignment with our thrive states, or what I call resonance. Whether you use Oktant or your own method, imagine what we could all collectively achieve if we were all living in our thrive states. In episode 1, I covered how to build a product landing page using the now deprecated Firebase Studio. Thanks, Google. There was a recent announcement that Firebase Studio will be sunset on the 22nd of March 2027, so I've moved my project across to Antigravity and updated the experience for the app launch. The updated landing page includes links to the app stores, a primer on how Oktant works, screenshots of the app in action, along with header links to the About, Build, Pricing, and Help sections with immediate access to the web version. In episode 2, I took you through how to create an interactive web prototype using Google's Antigravity IDE. The prototype allowed Oktant's founding users to get a hands-on feel of what the interface could look like, focusing on function over form to ensure a decent starting feature set. This phase helped me polish the domain model along with UI components to deliver the initial concept into a working experience. In hindsight, I should have spent more time in this phase, as some of the initial features still required changes to the domain model, which created some rework in the backend build. Regardless, there was a lot of learning that laid the foundation for the app. So let's dive into what that looked like. The prototype was a simple implementation where user data was stored in the user session. So there's no backend APIs or database to configure or manage. The main types, like the quest object, were simply stored as part of the front-end code in the types folder and used directly within the interface components with very little modification. This helped me clarify the application domain for the features I wanted to implement in the app launch before having to commit to a database-specific data model. For the full app version, though, I need to make some changes. First things first, I decided to convert my project repo into the Monorepo pattern, meaning that all my front-end, back-end, and shared package code could live in the same project structure. One of the primary benefits of this is atomic changes across the application, i.e., if I update a shared type that affects both the API and front-end, like a quest object, it's one commit in the same project versus multiple commits in different repos and the ensuing version/dependency hell. For this, I planned and executed with my code agent, Claude in this case, with the majority of the code moving between the app's front-end folder and the packages folder, which contains shared libraries for reuse. Later, I extracted the Resonance Points engine code into a shared package as well, and I'll touch on the API and Firestore service folders a bit later. The next step was planning the data schema conversion. I played with both Firestore Data Connect with Cloud SQL and Firestore before opting for the latter. I preferred the ability to adapt quickly as the Oktant model and feature set evolved, and capabilities like offline persistence in the app were a big win as well. A lot of agent planning and review came in again for both schema types, especially when planning out Firestore collections, permissions, and indices. The end result was a clear logical separation between database types stored in the Firebase service package, UI object types in the front end, and shared types for reuse. Plan in place, it was time to execute. I won't lie, this step was a bit hairy. When first generating the Firebase Data Connect types and subsequent changes across the app, the agent generated some 40,000 line changes, including a lot of GraphQL queries, which I don't know about you, but I think is pretty impossible to review comprehensively. Surprisingly, the app functionality was mostly intact, but after a couple of days of experimentation, I wasn't loving the implementation or what it meant for maintainability, scalability, and cost versus the Firestore option. The subsequent generation for Firestore was a lot more manageable, at around 5,000 lines, and with a few changes, was good to go. Lastly, for the API, I used NodeJS, Express, and Cloud Run. The API is used for several administrative and onboarding tasks in cases where shared Firestore collections come into play. For example, the crew feature coordinates quests between several crew members, so managing the right access permissions was best done through the API versus using client-side logic for single-user document management. And it's definitely needed in the case where you may have an embedded document like a user subscription, where you don't want the user to be able to maintain their own records directly and grant themselves free premium access. One of the Firebase features that made development a breeze was the Firebase Emulator Suite, which supports several products for rapidly building and testing your application in a local environment before shipping to the cloud. I plugged in Firebase authentication for basic username and password auth and to support Gmail and Apple's identity platforms. I spent a lot of time here tweaking the data model, API, and front-end with real-time changes enabled to ensure everything worked ahead of a proper cloud release. Using NPM scripts also helped simplify the process of managing the various services, enabling me to restart specific services if there were any errors or when hot deploy wasn't available. I did a lot of my local front-end testing on web and Android, deferring the iOS builds to test flight after doing a proper build and submit with Expo. While the prototype felt a bit more like a university project, my app tech stack started to resemble a real-world software project with a bit more sophistication across the build, deploy, and deliver toolchains. There's still more optimization to be done with regards to the use of the code and build tools, especially around automation and testing, and I'll look to create a video on my learnings on these later in the series. The use of Docker for the API, Google infrastructure, and Firebase product suite in general remains solid for the app. It's early days with only about 1,000 registered users, so time will tell on reliability, scale, and cost. But the initial ease of getting started, flexibility, and price model continue to make sense, especially in bootstrap mode for a self-funded project. I'm using Loops for marketing and transactional mail, and RevenueCat for delivering paywalls and managing purchases across the app stores. After living with them for a few months, I can definitely recommend these platforms for starting out. The generous free tiers offered by both really helped me get started quickly while I proved my app hypothesis without investing too early on in the development lifecycle. Also, a lot of customization is available on top of the many out-the-box features and integration points. I chose to have all of my subscription payments handled by the app stores. From the data I have in my customers, the preference has been for the mobile app version versus the web interface. So I figured it would be best to couple subscriptions into that experience as well. The App Store channels are expensive, even for a small startup at about 15%, but this includes payment processing, global tax remittance, and fraud protection, along with other benefits. The user experience alone just made sense for Oktant. I'll share the exact build steps and costs in a later video, and also make a version of this build pattern available so you can build your own web and mobile-ready apps, and simply bring your own keys to build away. So just a few takeaways from this build. Firstly, I scope creeped myself in the initial build phase, adding nice-to-have features while also jumping the gun with the back-end build-out. In hindsight, I should have spent a lot more time refining the full MVP working state before building to avoid rewriting whenever the domain model needed significant modifications. Second, starting with the Monorepo structure in place can also save you time when you're ready to build your backend. A simple project scaffold is enough to avoid refactoring time in future. Third, it's getting easier and easier to blindly trust code agent implementations on big and small plans. Agents getting better with each model release, but I think a good mantra with this is outsource your tasks and collab on your thinking. Don't just outsource everything. Context management in your project is also critical to manage different agent conversations in the codebase. There's rework and token savings with getting that right. Lastly, Firestore security rules are powerful and flexible. Check your rules and don't allow too much permission on your documents, like with the user subscription example from earlier. That's it for this episode. Thanks for watching, and I hope this video helped with the next steps in your app journey. In episode 4, I'll dive into how to tie the ecosystem components together from customer engagement platforms to submitting and releasing in the app stores. See you soon.